Hi, welcome to N5.5. This one is called equivalent fractions. So the outcome says, demonstrate an understanding of fractions by using concrete, pictorial, and representations to create sets of equivalent fractions. Now, you might already know that the word equivalent means equal. Okay, and they kind of look the same. They have the same root word. Compare fractions with like and unlike denominators. So already we have two words that you can put into your word book. Denominators is the bottom of a fraction. So if I have 4/10, 10 is the denominator. So we want to compare fractions that have like, which means the same, and unlike, not the same, denominators. So we could compare 3/10 and 4/10 and say, well, obviously 4 is bigger, so we have more tenths if we have 4 of them, right? But we could also compare fractions like 4/10 and 1/5. So we'll get into that. Those don't have the same denominators. Those are unlike. All right. So down here into, let's go with purple, down here in the indicators, you're using concrete, so we might, cut up a pizza or something. Pictures, physical models, you might have like blocks or something of equivalent fractions. We're also using symbols. So what I just did up here with these numbers, those are symbols. Model and explain how equivalent fractions represent the same quantity. So equivalent means same, quantity means equal. Verify, which means tell whether it is or isn't, whether or not two given fractions are equivalent using concrete, pictorial, or symbolic manipulation. So there's ways to compare fractions using pictures, and there's ways to do it with math, just with symbols. Generalize and verify a symbolic strategy for developing a set of equivalent fractions. So eventually we want to get you to the point where you don't have to draw it out every single time. We want to get you to the point where you can just do it with math, so using symbols. The next one, determine equivalent fractions for a fraction found in a situation relevant to self, family, or community. Explain how to use equivalent fractions to compare two given fractions with unlike denominators. Position those fractions on a number line. Justify the statement, if two fractions have a numerator of 1, the larger of the two fractions is the one with the smaller denominator. Well, that's a bunch of big old words, isn't it? So let's talk about that one for a minute. So we've already discussed the fact that the denominator is the bottom, so obviously the numerator is the top, and they're saying give the numerator a value of 1. So we have two fractions that both have a 1 on the top. Now they're saying if they both have a numerator of 1, which they do now, the larger fraction, is the one with the smaller denominator. So if I have a 5 on this side and a 4 over here, the larger of the two fractions is the one with the smaller denominator. So is that true? Is this a bigger piece of the pie? 1/4 versus 1/5. Well, the denominator is the thing that tells us how many pieces the pie is going to be split up into. And so we have these are not equal pieces because I'm a terrible artist, but if my pie is 5 pieces and I'm going to get one of them, or my pie is 4 pieces and I'm going to get one of them, can you tell by my drawing that this is the bigger pie? What if it was an even smaller number? 1/2. Definitely bigger. Okay. So if you're only getting one piece, if your mom says, you can have one piece of pie, well, just cut the pie in half and take that piece, because that would be bigger. It would be much bigger than this puny little 1/5 over here. So as your denominator gets smaller, as the bottom gets smaller, that means we're cutting the pie into fewer pieces. So those pieces are bigger and bigger and bigger. All right, on to our next one. All of these orange pieces represent 1/2. So they took a whole circle and they cut it into half. They shaded half of it orange. Okay, so they're all showing the same amount of orange. If the pie is cut into 2 pieces, then we say that there's a half shaded. One of the 2 pieces is shaded. But if the pie is cut into 4 pieces, and now we have quarters, here's a quarter, here's a quarter. So how many of the quarters are shaded? Well, 2 of them are. 2 out of the 4 pieces are shaded, or 2 out of 4. It still shows a half because those are equivalent fractions. 2 quarters is exactly the same amount as 1/2. And we can show that, we can prove it by these pictures. That is exactly the same as that. It doesn't matter how many times we slice up the pie. So now they've sliced those quarters into 8ths. They cut them in half again. So now we have 8 pieces of the pie. And how many 8ths are shaded? 1, 2, 3, 4 of them. So 4 8ths are shaded, which means exactly the same thing as 2 quarters, which means exactly the same as 1/2. So this would be your pictorial model, a picture. Here's how you do it symbolically. There is a law of fractions. I'm going to write it in nice big red writing at the top. What you do to the top, aka the numerator, right? You must do to the bottom, also known as the denominator. So this is the law of fractions. Don't ever forget this law. Super important. What you do to the top, you must do to the bottom. So in that previous picture where they split up those pies, what you're doing is taking this one piece and turning it into 6 pieces. Well, how did they do that? Well, they took that piece and they sliced it up 6 times. So they're saying that take these 4 pieces, also slicing them into 6, each one of them, and that would give you 24 pieces. So when you're doing math symbolically, just the math, any fraction that you have, whatever you decide to do to the top, and we're talking multiplying and dividing here, not adding and subtracting, because equivalent fractions has to be done with multiplying and dividing. So if I decide I'm going to multiply my fraction by 5, whatever I do to the top, I must do to the bottom. So what's 1 times 5? I hope you said 5. And 2 times 5? Awesome. So 1/2 is exactly the same. It's equivalent to 5/10. What if I decided to multiply those guys by something? Let's pick 2. What's 5 times 2? You got it. And 10 times 2? 20. Can you tell that, if you have 5 out of 10, that's a half. And if you have 10 out of 20, that's still a half. All of these fractions are exactly the same. They're just cut into different amounts of pieces. So this can also work when you're dividing. Remember I said equivalent fractions is all about multiplying and dividing. So if I have the example that they gave us up here, 6 over 24, what would I have to divide this guy by to get 1? Well, they divided by 6, and that gives you 1. So if I've divided by 6, this is my magical formula that I'm using, I need to divide by 6 on the bottom as well, because what you do to the top, you must do to the bottom. And 24 divided by 6 is 4. So your answer is 1/4, which is exactly the same as 6/24. So if you have a fraction like, let's just change colors, 20 over 120. Okay, there's a couple things you can do. The first thing I would do is divide by 10. Now, anytime you divide by 10, you would be removing that 0. But if I remove a 0 on the top, I need to remove a 0 on the bottom. So 20 divided by 10 is just 2, and 120 divided by 10 is 12, which is what I had over here when I lopped off those zeros. So sometimes when you have a 0 on the top and the bottom of your fraction, that's an easy way to reduce, is just get rid of those zeros. But if you get rid of 1 on the top, you need to get rid of 1 on the bottom. If you cross off 2 zeros on the top, you need to cross off 2 zeros on the bottom, because that would be technically dividing by 100. So whatever you do to the top has to be done on the bottom. So in order to get my fraction into lowest terms, 2 over 12, I can still divide by something because they have a common factor. What can I divide by? Well, I can divide by 2 on the top and on the bottom. 2 divided by 2, how many 2's fit in a 2? Well, 1 does. How many 2's fit in a 12? 6. So the original fraction that I started with, 20 over 120, is exactly the same as 1/6. So this is using symbolics, using just symbols, numbers, x's, division signs, to get our equivalent fraction. So here we have just some pictures. Let's look at this first one, the brown one. It's showing that there's 2 chunks shaded out of a total of 4. And the equivalent fraction, you can tell that this is half, right? The equivalent fraction that they gave over here has 1, 2, 3, 4, 5, 6, 7, 8 chunks shaded. There obviously is 16 in total because 8 out of 16 is a half. Okay, this guy, how many chunks total? 1, 2, 3, 4, 5. How many are shaded? 4 out of 5 are. So let's do this a little bit differently. If there are 3 not shaded instead of 1 not shaded. So before we had 1/5 was not shaded. Now we have 3 over something is not shaded. How can we find that something without actually counting all of these blue triangles? Let's do it symbolically. Let's go up to that equation and think, what did I multiply by to give me a 3? Well, it must have been a 3. 1 times 3 is 3. So now that I know that I'm multiplying by 3, what I do to the top, I must do to the bottom. And 5 times 3 is 15. So this fraction is showing 3 out of 15, but we didn't have to count them. We used math instead. 3 over 15. Okay, this pink one, that's an easy one. It's showing a half. There are 1, 2, 3 shaded, so we can use math. Times 3 would get you 3. What we do to the top, we must do to the bottom. So 2 times 3, there's obviously a total of 6 triangles. Over here, we have 1, 2, 3, 4 out of 6. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what is the total? Well, what did they do to that 4 to get the 8? What did they put here? What did they multiply by? 4 times something will get you 8. They multiplied by 2. So that's what I have to do down here. And there we go. Okay, so one of the outcomes, one of the indicators says that you have to be able to show equivalent fractions on a number line. So this green strip from here to here is showing 1/2. If this was a whole chocolate bar, that part would be half, right? So we can see that a quarter plus a quarter would still get us to that same spot. So 2/4 would be exactly the same. We can tell that an eighth and an eighth and an eighth and an eighth, so 4 of those, 4/8, is exactly the same as a half. And we can tell that 1, 2, 3, 4, 5, 6, 7, 8 of those guys, 8/16, is also getting us to that halfway point. Okay? So if this was on a number line from 0 to 1, remember that a fraction shows part of a whole. Make sure you're spelling whole with a W. If you don't, it's like a hole in the ground. This is like a whole chocolate bar, one whole thing. So a fraction shows part of a whole. So your number line would go from 0 to 1. Okay? All of these fractions mean that it's less than 1. So obviously 8/16 only gets you to this point. That's the same as half. All right, just a quick review before I let you go. If I have 8/16, how do I make an equivalent fraction? So you have two choices when you're going to make an equivalent fraction. You can multiply or you can divide. So I don't really want to multiply 16 by anything because that's going to get me a big old number and that's kind of difficult. So I'd rather divide if I can to make my number smaller. What could I divide by? Has to be the same number, top and bottom, that would give me an equivalent fraction. Well, I could just split them both in half, divide them both by 2, and 8 divided by 2 is 4, 16 divided by 2 is 8. But I could have also, instead of using 2, maybe I could have just divided by 8, go right over here, so divide by 8 and divide by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. So if you can pick the biggest number possible to divide by when you're doing equivalent fractions, you will end up with lowest terms. And now the fraction police will not hunt you down because they love lowest terms. Makes their day.